Welcome to the 9th week of this course. So in the last week we studied about hypothesis testing and all the basics related to that. Specifically we focused on one sample problems where how you can find out how you can test the claim that has been made about the population parameter whenever you have a single population and from there you are taking a sample. So based upon the test statistic and whatever results you get, how can you conclude whether the claim is correct or not? So we considered that for mean, variance and proportion. So here also we are going to work with mean, variance and proportion only, but in this case we would be considering two populations from which two different samples would be taken, and under certain criteria we are going to test the claims. So in this week we are first going to learn about the test for two means, then we will learn about the two variances, two proportions, then we will have in addition to this we are going to learn about chi-square test of independence and chi-square goodness of fit test. So if you recall, chi-square distribution is very important whenever we are dealing with the sample variance, right? Or whenever you are interested in the population variance and you want to estimate that. So chi-square distribution comes into picture there. In addition to that, it has an important role whenever we want to test the independence of the two variables and we want to also check the goodness of fit. So let us look at the first one. So we will begin with the test for the equality of two means. Test for equality of two means, and the first condition we impose over here is that the two variances are equal. Now what it says is that if you have two populations like normal, so mu1 sigma 1 square and normal mu2 sigma 2 square. So these are the two populations. Now it is imposing the condition that the two variances are same, so which basically means that we are working with the same variance. So we would just have mu1 sigma square and mu2 sigma square. And if you can recall, whenever the two variances are same and we want to estimate that, what we do is we replace that by the pooled standard deviation, right? In the sampling distribution chapter, if you can recall from there, like week 4 and 5, so in that we have studied that how this pooled variance comes into role. Now here our interest is in the difference of the two means, right? So we are interested to test a claim that is made for the difference of these two population means. So you have two different populations, you are taking two samples, independent samples from them, and such that their variances are same, then you want to test the claims about the difference of the two population means. So let us look at what is the test. Like first one would be the right tail test. So here right tail test, you can see that other things would be in the same way, like how you write the right tail test or the left tail test, what will be the test statistic and the rejection region. So we have discussed those in the previous week also. So here we are just going to generalize it for two populations. So in this case, if you see, the right tail test is that the difference between the two is greater than some hypothesized population mean difference. Okay, so d0 is a specified value and it is often considered as 0. So if I am taking d0 as 0, it means I am testing mu1 minus mu2 greater than 0, which essentially is mu1 is greater than mu2, and h0, so this one would be your alternative, and null would be that mu1 is less than mu2. So here basically you have that the mean of the first population is more than the mean of the second one, and in the null hypothesis it would be just the reverse of that. Okay, so right tail test, we know that null and alternative would be defined in this way, and the next thing we will have is your test statistic. Test statistic, you can recall from your week 5 lecture where we considered two populations and we were interested in the difference of the two sample means. So if you recall, we had that if x1 bar minus x2 bar minus mu1 minus mu2 over sp under root 1 over n1 and 1 over n2. Right? So these are the sample sizes for the two populations n1 and n2. Sample means are x1 bar and x2 bar, and mu1 and mu2 are their population means. And this would follow t distribution with parameters with degrees of freedom n1 plus n2 minus 2. Right? Now since we are calculating the test statistic under the null hypothesis, what we do is here mu1 minus mu2 is, there is an equality sign over here, right? So we can replace mu1 and mu1 minus mu2 by d naught. So that is why we get this test statistic. And the rejection region would be that for a level alpha, if it is specified level of significance and degrees of freedom, you would reject the null hypothesis if t star is greater than equal to the critical value. Okay, so we have seen last time also. So if you have something like this and T alpha is here, that is the critical value, and this is your region alpha. So this one would be 1 minus alpha. So you are going to reject the null hypothesis if the test statistic that you have falls in this shaded portion. Okay, that is the rejection region. Because so again you notice that this thing over here and this over here. So right tail test, you are working in the same direction as you have the alternative, right? This is just for you to keep these things in mind, okay? Because obviously why this sign is coming, you can see intuitively also it is correct that why it is aligned with this right tail test direction, because with the direction of the alternative. The reason is that you are going to reject if something is happening like this, right? If T star is greater than T alpha. So obviously you are rejecting that. It means that it is aligning with the alternative. It is something in parallel with the alternative. That is why only you would be rejecting it. Otherwise, had it been if T star was less than T alpha for the right tail test, if just you suppose that, then in that case you cannot reject it because it will be in the same way as you have the null hypothesis. So we consider this that you are going to reject the null hypothesis because this T star value that you have obtained is found under the null hypothesis. So always keep this thing in mind, that the test statistic is always calculated under the null hypothesis. That is why when we compare this T star value with your critical value, we say that if this is happening under the null hypothesis, then it means you have to reject the null hypothesis. Okay. So for this, I would suggest you look at theorem 4 in week 5 because there we obtain this pole variance thing. Okay. Likewise, you can have the left tail test also. So in left tail test, what will happen? That the difference of the two population means is greater than some specified value, and alternative would be that this difference is less than that specified value, right? So that is why we have the left tail, the name is left tailed, because we are dealing with the lower observations, like lower tail observations. Now again, the test statistic obviously would remain the same even if you are constructing right, left or the two tail test. So the test statistic remains same. The difference comes in the hypothesis, the way in which the hypotheses are framed, and your rejection region would change. The test statistic is same because we are all considering in these three situations, we are considering that you have independent samples but equal variances. So that is uniform for all three. So for a level alpha and degree of freedom, this n1 plus n2 minus 2, you are going to reject the null hypothesis if T star, that is the test statistic, is less than the critical value that you have found. Okay, so it will like this, then minus T alpha would be here, that is the critical value, and this would be your alpha. Okay. So you are going to reject the null hypothesis if the test statistic that you have found under the null hypothesis is falling in this region, in the rejection region. So obviously you are going to reject the null hypothesis, and you would say that since this is less than minus T alpha, it is aligning with the alternative in fact. So that is why you would reject the null hypothesis. And obviously negative sign over here indicates that we are dealing with those values which are less than the mean of the distribution, right? Because mean of the distribution, negative sign will come when this x1 bar minus x2 bar, if this difference is less than your mu1 minus mu2 or the d naught, right? So in those cases only you will get a negative sign, and in fact that aligns with your alternative hypothesis. So this is how you can perform the left tail test. Likewise, we can have the two tail test also. So two tail says that the difference of the two population means is actually d naught. Somebody has made the claim that the difference is actually, suppose, 5 centimeter, and here they are saying in the alternative that it is not 5, it can be anything less than or greater than. So they are not interested in what is the direction actually, whether it is less or more. They are in fact interested in it should not be same as 5, but it can be any other thing, right? So alternative is defined in this way. Again, your T star, your test statistic would be calculated under the null hypothesis, and for the given level of significance and degree of freedom defined in this way, if your absolute value of this test statistic is greater than equal to T alpha by 2, then you are going to reject the null hypothesis. So you know that obviously in this case, since it is two tail, your alpha will be split into two directions. So it is not a perfect normal distribution, so I am just drawing it. So this is alpha by 2 and this is alpha by 2, and this would be 1 minus alpha, so that the area below the curve is 1 minus alpha. So if this happens or this happens, you are going to reject the null hypothesis. Okay. So this is how you can perform different tests for the difference of the two means whenever you have independent samples coming from the normal distribution and you have equal variances, right? So since the moment we say equal variances, then we know that if it is unknown, then it has to be estimated using the pooled variance or pooled standard deviation. Okay. So now let us consider an example over here. So to investigate the performance of light bulbs produced at two different manufacturing sites operated by a company, an evaluation was conducted. The lifespans of the bulbs measured in units of 1000 hours were documented. The data indicate that the variability in bulb lifespan is consistent across both plant A and plant B. So you have the lifespan of light bulbs from plant A and plant B. So 10 values are given to you from both the plants and their lifespan is given. Okay. You have to determine whether there is statistical evidence to support the hypothesis that the mean lifespan of bulbs from plant A, that is if you denote it by mu1, then it exceeds plant B by more than 0.5000 hours. And you have to use the level of significance at 0.05. So in this case, since it is given that the variability is consistent across both the plants, it means that your variances are same, and here you can apply your result which we have just now studied. Now let us understand whether it is a one-tailed or a two-tailed test. So you have to find out, if you read the last statement from there, if you denote mu1 or mu A as the average lifespan of bulbs from plant A, and this is from plant B, this would be greater than 0.5. So this is your hypothesis. So if I just show you, right? So alternative is this, and you want to reject this hypothesis, because reject the null hypothesis so that you can accept the alternative and you can finally verify whether this difference of the two population means exceeds 0.5 or not. So here basically based upon the data that you are given, N1 and N2 is 10, x1 bar and x2 bar is, you can calculate from the 10 observations that are given. Likewise, you can calculate the sample variances also. What will be the degree of freedom? The degree of freedom will be N1 plus N2 minus 2. So 20 minus 2, that is 18. Okay, so you can use the t-test that we are using in the previous one to test the equality of the two population means with equal variance. Next, what you're given is your alpha. Okay, that is the level of significance is given to us. Now we are going to find the test statistic. For test statistic, what do we need? We need the sample standard deviation or the pooled variance. Okay, so the formula for the pooled variance is basically, you can just consider square root of this. So square of this, so n1 minus 1, s1 square plus n2 minus 1 times s2 square, n1 plus n2 minus 2. So it is a weighted average of your sample variances. Okay, so since your sample standard deviations are of a similar size, pooled estimate of the common population standard deviation is this. And if you substitute these values where n1 and n2 are 10 and sample variances, this would be 2 over here. Okay, so what are the values? This is 3.242 and 3.915. So you can see that they are very close, right? And we have that rule of thumb also. So this pooled standard deviation comes out as 1.892. Once we have the pooled standard deviation, we can substitute in the formula for T star. So T star said that x1 bar minus x2 bar. Okay, so these are the values which are given to us. D naught is the value under the null hypothesis. So D naught is 0.5. SP we have just obtained above. And when you substitute it, it comes out as 0.786. Okay. So basically you see that it is a right tail test. So if you have to adopt the rejection region approach, then for alpha at 0.05 level of significance, you can see from the T table that the value corresponds to 1.734 at 18 degrees of freedom. Okay, so you can either look at the table, so you will go for the corresponding degrees of freedom and the alpha value, and from there in the table you can find this 1.734. And if in case you are unable to find from the table, you can just write the code for that in your software, that is Python. So we use it there. We will see it in this course in this week also. Now if you see that T star basically was minus 0.786, right? Minus 0.786, and this obviously is very less than 1.734. So if we cannot reject the null hypothesis, we don't have sufficient evidence to reject the null hypothesis, and we can conclude that average lifetime of plant A is more than 0.5 hours, 1000 hours, less than equal to the average lifetime of plant B. Okay, so you reject the null hypothesis basically when your T star is greater than T alpha value, right? In this case, it is not happening. So you fail to reject the null hypothesis. If you fail to reject the null hypothesis, it means that we are basically saying that this is actually happening. So the claim that was made initially that the difference of the two population means would be greater than 0.5, so that is not true. Okay. Likewise, if you want to apply the p-value approach, so p-value obviously we know that how it can be calculated in a right tail test. So it would see that probability that t is greater than t star value minus 0.786. Again, p-value you can easily calculate using your software Python. Just give a simple command and it will give you this p-value. So it would be 0.779. Again, if you compare that with alpha, so obviously it is greater than alpha, so you fail to reject the null hypothesis. Okay. So this is what you can conclude from here. So you have seen that how you can test the hypothesis or test the claim that has been made about the difference of the two population means by using the result, the first result that we have seen today. Okay. Obviously, in many situations you may come across the scenario where the two variances are not equal. So if the two variances are not equal, you cannot use the pooled sample variance concept. Okay, so you have to look at these two separately. So you will have this cannot be used. You will have the sample variance for the first one and the sample variance for the second sample. Okay, so you have unequal variances. Right tail test. So right tail means that alternative would be defined in this way, right? That the difference of the two population means is less than the specified value, hypothesized value, and alternative would be the other way around. Now what would be the difference in the test statistic? The test statistic would be different because here we are not going to deal with the pooled variance or the pooled sample variance, but in fact we would be dealing with separate to S1 square and S2 square, as I just said now. It is calculated under the null hypothesis. If you can recall that what it is, we obtained this result earlier in theorem 3, week 5. Okay, so if you look there, if you recall, then we had this test statistic and it was following t distribution with beta hat. Right, and beta hat was of this form. So beta hat was the degrees of freedom that we had. Okay, since it is the same situation that we had there, so we can use that result over here. Okay, so that was the reason we studied the sampling distributions before. Right, so that was introduced as a tool for the data analysis. So you can see that how we are using it simply because there we studied all the concepts and now we are just picking them from there and using it on our results depending upon whatever situation we are in. So in this case also, so this I believe you can just cross check this from your theorem 3 week 5, so you will be able to recollect what we discussed over there and why this degree of freedom looks like this in this way. So here we are going to reject the null hypothesis if this t star, that is a test statistic you have calculated, is greater than equal to this critical value. Okay, so you will reject the null hypothesis if it is greater than that, obviously because it would align with your alternative. Okay, likewise you will have the left tail test also. So here in the left tail test, alternative would be that the difference of the two means is less than some hypothesized value. Again, the test statistic would be this. And you would be rejecting the null hypothesis if it is less than minus T alpha. So if it is falling in this region, then you would say that you would reject the null hypothesis. Okay. So other things would remain same with just the difference that rejection region would keep changing here and hypothesis. So test statistic, once you have identified what is the test statistic for a particular situation, you can keep on using it for different cases, whether it is a right tail, left tail, or maybe a two tail test. Next, you can have a two tail test. Again, the test statistic is same. Rejection region would be mod of, or you can say absolute value of this test statistic is greater than equal to T alpha by 2 with these degrees of freedom. Okay, same thing. So here you have minus T alpha by 2 and this side you have T alpha by 2. To understand this, let us consider an example. Suppose a study was designed to compare the effectiveness of two different diet plans. So diet A is you will have a low carb diet and diet B is of low fat. The goal is to test if there is a significant difference in mean weight loss between the two diets for the 30 participants in both these diets. So participants' weight loss was recorded after 6 months on their respective diets. And these were the observations. that mean weight loss was 8 and 6 and standard deviation was 3 and 4. Okay, so for both the plans or for both the diets, 30 participants each were chosen, and after 6 months, so they were given certain diet. So the first group was given that a low carb diet was planned for them, and after 6 months it was observed that mean weight loss, on an average they lost 8 kgs, and in the other one they lost 6 kgs, and in the first one the standard deviation is 3, and in the second one you have 4 standard deviation. Here your goal is to test if there is a significant difference of mean weight loss between the two diets. Okay, so you have to test the alternative that mu A is greater than this, right? If the diet of the first one is better than that of the second one. So here basically if you see D0 is 0 in this case, or I'm using A over here, you can use mu1, mu2, same notation. So what it will mean that mu1 minus mu2 is greater than 0, which essentially is that mu1 is greater than mu2. So either you write 1, 2 or AB is same, right? So these are the mean weight loss. Now here we will be using the Wells t-test that we just studied, because the variances are unequal, right? And here if you substitute these values, you know the means for them, 8 and 6. D0 would be 0, because here it is mu A minus mu B is less than equal to 0, right? So under the null hypothesis this would be 0. You know the sample variances for both of them, and the number of participants in both the cases is 30 only. So what you get is 2.191. Degrees of freedom can be calculated. Okay, so you just have to substitute the values of the sample variances and the sample sizes in this formula, which is pretty simple, and what you will get is that this value is approximately 53.783. so you can take 53 also. So if you solve this by the rejection region approach, then you will see that the critical value at alpha 0.05 and degree of freedom 53 is approximately 1.674. Okay, critical value is this, and your T star value that you have obtained is more than the critical value, so you reject the null hypothesis and you can conclude that diet A is more effective for weight loss as compared to diet B based on the study that was conducted. Okay, so idea is same, right? You are defining a null or a hypothesis first, and then you are calculating the test statistic, finding the critical value and rejecting it, or if it is the p-value approach, you will find the p-value. The difference is coming in the test statistic that you have to use. It means that you have to identify what is the background for that, what is the scenario, and what will be the corresponding sampling distribution with which we are dealing, right? The moment you go back to your week 5, you can immediately recollect that, okay, this is a situation which corresponds to Wells t-test, and we have studied that earlier, that what will be the sample statistic over there and what will be the degrees of freedom. So we will just simply use them over here. Okay, so this hypothesis testing would be a cakewalk if you just keep in mind what you have done earlier, right? Because whatever you have done in sampling distribution would be applied in this case. Next, you can also find the p-value approach, and in this case probability that T is greater than T star, so obviously this comes out as is a right tail test, so you will get approximately 0.0164. Now since the p-value is less than 0.05, we reject the null hypothesis in favor of the alternative. Okay, so you are going to reject the null hypothesis and you would conclude that diet A is more effective for weight loss compared to diet B among the study participants for a period of 6 months. So this is how you do your hypothesis testing. If you are interested in the difference of the two means, so the first case that we studied was that the two variances are same, or in the second one we studied that the two are different, right? So in both these cases, what was common, that we were taking independent sample. Obviously, we can come across situations where these samples are not independent, right? They are dependent. So if you can recall from earlier lectures, that whenever that is the case, we try to remove the dependency by considering the difference in the corresponding values.